Thank you. Now calling Tony Randall from Bell on stage.
Good morning. First thing I want to hold up is, and I'm doing this because I'm putting in a plug for him, but you notice he's sitting outside on the table. Tony Molinaro brought these from the International Helicopter Safety Foundation. There are 140-some products on here that came from EHS, ESPNR, USHST, and they're all safety related. So, and they're in multiple languages. So go ahead and pick one of those up if you are an operator or know an operator who might benefit from having some of those products that are on there. Anyway, thank you. And I'll now roll into mine. Thanks for having me. I'm the manager of continued operational safety for Bell. I appreciate you having me here today and to join the rest of my colleagues in this event. Second time I've been here. I applaud everybody who comes. I do many of these on the U.S. side as well, and it's always great to have a good audience and a good set of people who are interested in making this industry safer. So, and that's kind of what I want to talk about today. You can see up on the slide right now, my briefing today is going to be mostly about Bell products and what we've kind of done internally to increase the safety of our current product line, what we're doing in our new innovations and our upcoming product lines, and then a couple other activities that we are doing that also benefit safety internally. But kind of what I want to talk about first is a little bit of the current status of the industry. And this is just to kind of baseline everybody. Excuse me. A lot of the things I go to, everybody's kind of baseline because we all do the same thing. I don't think that's the same thing for this room here. And I just kind of wanted to go over it real quickly. So industry-wide, you can see the current commercial fleet is in excess of 32,000, although when I was reading the Rotorcraft Safety Roadmap, I noticed that it said over 40,000, so kind of depends on where you get your numbers, but we'll go with the 40,000. And of that, Bell has approximately 11,850, and I think of the end of this month, we'll have 853 there. So 8,200 or more are active, and that excludes the Bell 47, which we sold the type certificate 4 years ago. Those two charts are not necessarily for you to read. They're not meant to be eye charts. They're just to show you the trends. The one on the left is the EASA Annual Safety Review. It's about a decade's worth of numbers for accidents and fatal accidents and accidents. And the one on the right is the U.S. one. And the top line is accidents, and the bottom line, the red line, is fatalities. You can see fatalities are kind of flat. But the point to both of those is that the slope of that line is not down like we would like it to be, right? We are nowhere near part 121, and maybe we'll never get there, but we should strive for that, right? So that's all that was meant to show, is that we're still working on issues. We still have our problems. What are the issues? The issues listed on the top there, excuse me, come from the U.S. data, but when you look worldwide, those issues don't change. They may rearrange themselves just a little bit, but they're all still the same issues worldwide, so it doesn't matter what country you're working in. Those are normally the top reasons for cause factors. What can or are we doing as an aircraft developer and manufacturer? So we take a design conditions in on this. We're trying to make, you very rarely see for any of us, for any of our competitors or Bell, airworthiness issues usually are not the big problem. They're not the thing that you see listed on on the majority of the accidents. Airworthiness issues are usually a very small part of our accident cause factors each year. And so what you have mostly is human factors. So you can kind of see there at the bottom that we try and work on that. We internally, we maintain a really robust database of our Bell product lines. We get the data from accidents, incidents, our product support engineers, warranty data. So we have a pretty good idea of where and how our fleet is used, which helps us when we go backwards and try and redesign the actual aircraft for man-machine interface based on accidents and usage. So on those issues, what's the industry as a whole doing about them? In review, and I'm not going to read all of those, so you can read them if you like, but I'm just going to kind of talk to them in general. In reviewing the safety promotion tasks and comparing them with the USHST, which is the United States Helicopter Safety Team, helicopter safety enhancements, there's a similar theme, and both are data-driven, but there's differences in how the issues are being attacked. And as I listened to David talk this morning about some of the EASA stuff that's going on, and I read the safety roadmap and some of the good work that's being done there, I think next year's the event for next year would be a good opportunity maybe from somebody from the U.S. team to come over and brief the helicopter safety enhancements and how we're attacking some of these issues. They're very similar to what's going on with the roadmap, but they're different. And so they're both data-driven, and I think there's some synergy that we're actually losing out on there by not coordinating that amongst these groups that are trying to solve these issues. Excuse me. And then you see a bunch of actions that most of us are participating in. Most of the OEMs participate in all these groups. So we as an industry, at least from the manufacturer side, are doing a lot of good work. And there's a lot of you out there that support us, and we appreciate that. Where can the OEMs continue to contribute? Sorry, got lost. These are the things that we've been working on, and I know most of the OEMs are. The interesting one's the safety rating concepts. I'll talk a little bit about that later on, but I know David hit on it, and there's a couple of efforts going on right now. But we're participating in all of these, and I think they're all very important. So that was the industry. I'm going to talk a little bit about Bell. This is our current in production models, with the exception of the Huey, but we are doing some Huey mods still, so that keeps that line active. We have, for those of you who don't know, we have aircraft certified in both Canada and the U.S. with validations across the world, so we're working both sides of the border over there. As far as the field and fleet efforts, crash-resistant fuel systems have been in the news quite a bit over the last 2 or 3 years, and as well they should be. This is kind of where we are right now with our in-production fleet. You can see the 412 is compliant to an older standard, and I got some stuff on a later slide that tells you how we're bringing it up to a current standard. 206, it is what it is. They're older aircraft. They were certified a long time ago, but they're not in production anymore. We do have kits available for the older models up through the L1 that bring it up to the L3 and L4 standard. Small weight penalties, but we did go out and work that pretty diligently over the last couple of years to try and bring it as close to standard as possible. And then you see everything else there is compliant. Kind of wanted to show this one that we're kind of proud of this one. This is a bird-resistant windscreen. I won't say it's certified to a standard for being bird protection, but if you see the left picture there with that red circle, that's the damage that's then shown in the right circle. And this is a polycarbonate windscreen. And that center one, this got hit by a buzzard that was 7 or 8 pounds, a small buzzard, but it's still a buzzard, and did not puncture the windscreen. So I'm going to show you on the next slide actually how this works. Can you play the video from back there? I don't know that I can play it from up here with this. There you go. That's a 2.2 pound projectile simulating a bird, and you'll see it skin up to the upper right. It'll do the same thing if it hits the left windscreen. It goes up and outboard. That way it stays. It's kind of the window design helps that, but we kind of liked it that way, so we helped it a little bit with the wind shape design to do that, so it kind of stays away from the controls up on the head too. So that was a 2.2 pound bird at VNE plus 10 for a 407 windscreen. Now we have those for the 407, the 206s, and the 429. So we spent a lot of time and hard effort on that, but the results have been pretty good so far. We've had multiple bird strikes on these out in operator for multiple operators, and none of them have penetrated yet. So, oops, there we go. All right, continuing with 407. Here's just some item of interest that we have. These are all kind of, we predict them as safety items. Glass cockpits are kind of interest. I've got an internal study going on right now. Our 407 fleet's a pretty good fleet to do this on because we have an older fleet that is non-glass. And then we cut over to glass a couple years ago, and it's all glass now. But it gives me a good comparison between a glass cockpit and a non-glass cockpit, between accidents and incidents, and what the differences might be there on the situational awareness that the glass cockpit brings about. So it's a good case study. Kind of doing that now. Don't have any real data from it yet, but I hope that it shows that glass has changed at least some of the way that we crash aircraft and enhances situational awareness. The pulse light system, I'll go down to that one. We just we went in partnership with a company. It's their STC. We actually offer it. It's just the flashing light. They did a bunch of work on it, but it's Pulse Light's the name of the company, and they are on a lot of platforms out there for a lot of operators, not just the 407. They were well established before we got into this, but some of the metrics that were behind that showed some really good promise for doing away with bird strikes. And it also ties into your TCAS, and if you get a TCAS warning, it'll automatically come on so other people can see it as well. And then, yeah, we just got the single engine IFR, but a couple of folks are working towards that now. So, but we do think that as long as competency and currency are maintained, is a better option than scud running. 412 CFR crash-resistant fuel cells. We do have 2 phases. The 412 was an older standard. It didn't quite meet current standards. So there was two issues that came out of the ARAC, and part of it was the Perlmutter Amendment. And so we should be in compliance with that before April of this year. Have to be, actually. And we have a plan going forward to do that, and it should not be very difficult to do. And then the second part will be fully compliant to the new CFRS standards, and we anticipate that by the end of 2020. So that airframe will have a long and viable life. And you see at the bottom there, we actually are going to do a drop test in that aircraft, so drop test in structure, just to prove it out. This is just kind of an add-on here. So the 412, none of the Huey models have ever had crash-resistant seats in the back, so energy attenuating seats. So we got a project going on in the 412 right now to do those in the back, and then there's a potential that those can be transitioned into the 212 platforms as well, because there's a lot of those still flying. 505, new aircraft, as you'd expect. It's to the latest standards, so 2747 for the FAA and Amendment 3 for 27 here. And then the 429 is still fairly new, so it's pretty close to being with the newest amendments. Okay, this is where the fun stuff is. Actually, this is where we get into the interesting stuff, where we're hopefully making stuff. That video on the bottom left there wasn't really supposed to play. It was just supposed to be a picture. Sorry. Anyway, so this has to do with crew station design and development. So as we came forward into our new product line, which is obviously the 525, it's a larger cockpit, and it's an aircraft utilized for more of a airline type situation, point A to point B, and a lot less for what other rotorcraft are used for when we go out to unprepared surfaces and unknown zones. So the design in this, the cockpit was larger. It had a lot of extra things like you might find in an airliner, a more advanced cockpit, I should say. And so with that comes the requirement to go into it with a little bit more rigor than we possibly have in the older aircraft that didn't have as much technology involved. And so we used a lot of design stuff for that. I'll get into it on a couple more slides. But we used 251302, which is actually a aviation Part 25 rule, excuse me. It's not required for 27 or 29 right now, but the things that come with that we found very enhancing. We went out and hired somebody, and we instituted a crew error management program, which allowed us to do a lot of upfront work on the cockpit design, both visually and then digitally, to figure this all out. And we think the cockpit came out very well. We've been working on a lot of man-machine interface and situational awareness builders. You know, human factors, we talked a little bit about on what's causing the accidents. So human factors, a lot of it is not necessarily the human. Sometimes it's the man-machine interface. And so we want to do as much as we can to build the situational awareness of the pilot and the aircrew and make it as easy as possible for that person to fly. And for the long flights, you know, you got a 525 level aircraft or a larger aircraft with longer legs, you know, you get into a fatigue at the end of the days as well. So we have a lot of these, and a lot of these are not particular to our models, right? But we're trying to do interface with these that are unique to what we're doing, trying to make them so that it meets the newest standards and also is as friendly to the aircrew and to the pilots as possible. So You can see we've added a lot of these. I think the top one with the power limiting and speed queuing, I think the stick feedback, I'm not sure if anybody else has that, but so we've added a few things, we keep adding them. Hands-off retrim for the single engine Cat A operations is pretty nice. It'll actually correct for a fault, so if you have an aircraft AEO to OEI type situation, it'll seamlessly transition that for you and help the pilot get through that. A little bit more about the 1302. Like I said, it was transport category rule. It was helped us with a lot of the safety enhancements to evaluate them and to adjust them as necessary to make them more friendly and user-friendly, user accessible to the pilots and the air crew. Overall, assessment of the cockpit and crew tasks, and it decreases the interface errors, which is kind of what we were getting at with the whole thing. And then we do a lot of simulation and improvement of that before we get the thing to the fleet. And hopefully, by the time we deliver the aircraft, it'll be as good as it can be. Let's talk a little bit about fly-by-wire. This is probably one of the bigger things that we've been working on for the last couple years. You can see a lot of you've seen with other aircraft, especially with urban mobility stuff now, that there's a lot of things going to fly-by-wire. And I'm not getting in my brief, I'm not getting into urban mobility at all. I'm just talking traditional helicopters. But we are looking at this for across the board for urban mobility and some of the other product lines that we're working as well. And we probably see this as the way forward with the rest of our fleet or any future models that we build. So it does have a triplex system. The 525 has a triplex system and it's fully capable. Any of those systems is fully capable of flying the aircraft. It allows you to do system separation for zonal threats because you don't have all the tubes and everything, the hard tubes going through the aircraft, which also eliminates mechanical linkages and the associated maintenance issues that come with those. And it also allows you to design your cockpit controls basically any way you want. 525, we've got side stick controllers, and I know there's other aircraft out there with those. And for long haul flights, it's kind of sitting like that is kind of a little bit more ergonomic and it's a little less fatiguing than a traditional set of flight controls. Simplified, so you can do single axis controls. My example on that one is if you just want to go to a hover, you can pull a collective up and it'll set you in a hover and there you'll stay. So it was pretty intuitive to fly once you've done it too. Automatic transition between flight regimes, I kind of mentioned that before, but that was if you have a failure, it'll automatically do it. If you have an auto rotation, so both engines for some reason go out, it'll automatically start you into the auto rotation, hunt for the airspeed, and make sure you're within the parameters for whatever failed condition you have. So there's a lot of potential there with the fly-by-wire. So pilot assist, just talked about reconfiguring. Tactical viewing and the limit trimming, you can reset those for whatever condition you're in. Unusual attitude recovery is also there, so is auto rotation entry assist. Now, the bottom part for the automation to autonomy is where we're going in the future, and I think a lot of people are headed this direction. I know a couple of our competitors have a few approaches that they do autonomously and some aircraft stuff that they're working on. So what fly-by-wire helps you do is it's a little bit easier to go to the whole autonomous mode and to also do automation for portions of modes. So you've got auto couple, envelope protection, and then you can go to detect and avoid integration, moving on to optionally piloted, and then the full autonomous if you need it or when we get there. And we'll get there, and we're working on some of that with some of our products right now. I stole this one. The main reason I stole this from the 525, and rather than rebuild it, it shows a nice picture. So kind of what I want to point out on this, it's not really, you don't really need to read the little blocks, especially in the back. You might not be able to see them, but it's indicative of where we like to go for all of our multi-engine vehicles. It minimizes the probability of loss of lube events, maximizes safe flight time if such an event does occur. We did this by eliminating the high-speed bearing and gear meshes that associate the heat. And then we separated we have separate reduction gearboxes for each engine to allow for the elimination of the high-speed planetary gear. So we took a lot of the high-speed stuff out, which reduces the heat. And then this current architecture has actually demonstrated run times greater than 60 minutes for all primary paths with loss of lube. So we're pretty happy about that, and that's why I stole that slide rather than rebuilding it. Lastly, I wanted to cover a couple other things we're doing internally to enhance the safety posture of our products, actually. So we're going to all IETMs for everything that we build right now. 505 came out with it. 429 has already been transitioned to IETMs. 407 will be complete by the end of 2019, and you can see the 412 will be done by second quarter next year. So by mid-year next year, we'll be all paperless products for all of our in-production models. Safety rating schemes, I hit on that a little bit earlier, but let me get a little bit more into it right now. So we're working with Project Cassiopeia, which was mentioned earlier. We're working there. We have had some discussions on the EASA side. We've been briefed on it. I've heard the FAA is doing something. I haven't heard more than that. But we are participating, as well as some of our industry partners, i.e. our competitors as well. But in this, I would think there are industry partners. So I do have to say that that's one of the best things on the OEM side is I do have a couple of them in the audience right now, and we serve together on things like this safety rating scheme and some of the other IHSF and some of these things. And to my OEM colleagues, it's been a very robust relationship in trying to make these things work so that our industry is much safer. As far as us, though, we also have a robust system safety process that we use internally. We're actually moving on from the ARPs now and trying to add things like model-based systems engineering to better capture our total aircraft so we can enhance the safety as the life cycle of that aircraft goes on. And then design and manufacturing safety management system. We actually were the first OEM to get it for the FAA acceptance in the US, and we are doing our worldwide company, so all of our facilities worldwide will fall under the design and manufacturing SMS. And for those who haven't done that yet, it's a eye-opening experience, and I think SMS and the just culture that comes with it is really helping to drive corrective actions into our products that are at the right level and are really going to help us. So, and I had one more slide, but I deleted it because I knew I'd be over. Thank you.